Good morning, grade 8s, and happy greetings to each and every one of you today. Welcome to WorksheetCloud Grade 8 Natural Sciences lesson. If you have a question during the lesson, send an email with your question to grade8@worksheetcloud.com. This is wishing you a wacky Wednesday and a lesson full of wonder. So why don't you go off now and get a wacky cap or a wacky wig or a wacky Alice band, or go and do your hair in a wacky way and come back and join us for a lesson filled with wonder. I thought you probably wouldn't be able to concentrate with me with the wacky purple hair on. Anyway, so I took it off, but I am Mrs. Ernston, the WorksheetCloud Grade 8 Natural Sciences teacher. Remember to take notes as we discuss things in our online class today, and I've got to say, I love your wacky hairstyles. So the content we're going to be covering today is an introduction to the particle model of matter, and I'm sure you've covered this in grade 7 and grade 6 and even maybe grade 5. We're just going to be focusing on the properties of the different states of matter and how can they be explained in terms of motion and arrangement of particles. I also need you to be able to explain why a model for the structure of matter is needed. You are going to model the arrangement of particles in solids, liquids, and gases. And I need you to be able to use the particle model to explain observed phenomena linking the energy of particles to temperature changes. We'll start today with an activity called I think, I see, I wonder. So I have a question for you. If 100 centimeter cube of water is mixed with 100 centimeter cubed of ethanol, the volume of the mixture is 198 centimeters. Why is the combined volume not 200 centimeters cubed? So that is really something for you to think and wonder about through the course of the lesson. And I'm sure somewhere in today's lesson, I'll be giving you the answer. So just so that you can see the question, here we have 100 centimeters of water. Here we have 100 centimeters cubed of ethanol. And if we have a look here, this line should be slightly higher up here if it were to be 200 centimeters cubed. But you can see this line is just below 200 centimeters cubed. Now, how can that be? So here's something else I want you to engage in. We have a scrummy slab of chocolate and a raw egg. And I want you to think, what would happen to the chocolate and the egg if we heated them? So I'm going to give you a few seconds to think about what would happen. This is actually so interesting. The chocolate that is a solid would have melted, and we would now have yummy, pouring, liquidy chocolate. And the egg that's liquid, is going to solidify. Now, how can that be? But another thing I want you to engage in, and that is, if we have two syringes, and we fill one syringe with the same amount of air, and the same syringe with the same amount of water, and we put our finger on the tip of the nozzle of the syringe, and we try and push the plunger down, what do you think is going to happen? Now, I don't know if any of you have got a syringe lying around at home. If you do, pause the video now and go and do this activity, and then come back and let me know what you found. So what I'm guessing you found is that the air or gas in a syringe can be compressed. So the plunger here should be able to move down, but when we try and compress water with our second finger on the nozzle, the plunger can't move. We can't compress water. Now, why? Something else is that if we have a look at the cylinders, the gas cylinders that you can use for your gas browser when you go camping, or if some of you have seen these scuba divers with these gas cylinders, what is inside here? It says there is a gas, which means the gas inside here has been compressed. How can we compress this gas? Because there are spaces between the particles of matter. Most substances are made up of particles that have spaces between them. And due to these spaces, matter can be compressed. So to answer your question with the syringes and the liquid, the amount of compression possible indicates the relative spaces between the particles. So if we go back to this diagram here, the fact that we can compress air means that there is lots of space between the particles when compared to the liquid. And it's more difficult to compress the liquid because there's less space between the particles. Here's another concept I want you to engage in. How come perfume sprayed in one part of a room will spread out and can be smelled throughout the entire room? Think about that for a moment. So the answer to that is the movement of particles of one substance between the particles of another substance is called diffusion. So the particles will move from an area of high concentration to an area of low concentration. So that means from where there are many to where there are few. And another thing for you to engage in, how come sugar dissolves in water? So here we have our sugar and here we have our water. How come when we put the sugar into the water, it seems to disappear? So when sugar dissolves in water, the water particles attract the sugar particles. Water particles attract the sugar or coffee granules and then pull them apart so that they can spread out in the water. Look at this beautiful diagram of this iceberg in Antarctica. Can you remember learning that matter can exist in 3 different states? What are those 3 states called? Does this ring a bell? Solid, liquid, and gas? So this diagram compares the particles in a gas to the particles in a liquid to the particles in a solid. So how does this relate to an iceberg in Antarctica? Well, each state of matter behaves differently, and the particles in each state behave differently. So if we have a look at the picture here, water can be seen in 3 different states: as a gas in the clouds, as a solid in the iceberg, as a liquid, as in the water. So water is a compound that we represent as H2O. And there are forces of attraction and repulsion between the particles of matter. So here is a diagram of a water molecule, and here is what the water molecule will look like represented as a gas. Here is what the water molecule will be represented as a liquid. And here is what the water molecule will look like represented as a solid. So if we have a look at this diagram here, I want you to see if you can do a matching columns activity. Here I've got pictures, here and here and here. Here I've got terminology, gas, liquid, and solid. And here I've got descriptions. What I want you to do is I want you to pause the screen now, and I want you to see if you can match the diagram with the word and with the definitions. And here are the answers. This is a diagram of a solid, and if we have a look, the particles are closely packed in a regular arrangement. The particles do not move, but they vibrate. There are very strong forces between the particles, and there are very small spaces between the particles. So here you can see the small spaces between the particles. This is a diagram of a liquid, and in a liquid, the particles are loosely arranged but still close together. The particles can move quite fast and they can slide past each other. Strong forces between the particles, however, but they are weaker than in a solid state, and there are small spaces between the particles. If we have a look at this diagram here, that's of a gas. And if we have a look at the arrangements of the particles, there is no particular arrangement. The particles move very fast. There are very, very weak forces between the particles, and there are very big spaces between the particles. So well done on doing that little activity. I hope you got everything right. Now we're going to do a little exercise here. And I think this is a great exercise to do because it gives you a chance to be creative and it gives you a chance to make your thinking visible. So what I want you to do in your books is I want you to draw a table like this. And you can either make this a full page, so a full A4, or maybe you could do 3 of these on a page, 1 for solid, 1 for liquid, 1 for gas. So that will probably be the best to save some space. So you need to do 1 of these diagrams for a solid. And then when you draw the diagram, I want you to, so you're going to draw a rectangle, then you're going to split the rectangle in half vertically and horizontally. In the middle, you're going to put the state of matter that you're looking at. And then what I want you to do is I want you to write a definition for the state of matter. I want you to write down what are the basic characteristics. Then I want you to give yourself some examples of what is a solid. And then this is a great creative activity that is going to make your thinking visible. So for example, when I say the word solid to you, what color do you think of? And when I say the word solid, what symbol? Now, there is no right or wrong answer for this block down here. This is where you are making how you think visible, which will help you remember it better for a test. So, this is what your visible thinking diagram is going to look like for a solid. This is what your diagram is going to look like for a liquid. And this is what your diagram is going to look like for a gas. So you can pause the video now while you go and sit and do your visible thinking diagrams for a solid and a liquid and a gas. If you don't want to do it now, you can always do it as an activity later on and you can move on with the lesson. The other thing that I think is really, really important for you to do is make a summary that looks like this table here. This is going to be really beneficial when it comes to studying for tests and exams, and it is a beautiful way of summarizing your knowledge of solids, liquids, and gases. And you're going to add what the diagram looks like, the shape and volume, the arrangement of particles, the distance or spaces between the particles, the movements of the particles, and the forces between the particles. What is important when you are practicing these tabulating skills is that in this column here, we have the descriptions. So when you've got shape and volume, everything in this block must be shape and volume of a solid. Everything in this block must be shape and volume of a liquid. Everything in this block must be shape and volume of a gas. You will be able to get this worksheet from our activities worksheet section, and you will find the memo there as well. And this is a great activity to do when you are preparing for your tests. I want us to just revise going over the compound water and how this links up with solids, liquids, and gases. So that is our water molecule, made up of one oxygen atom that is red and two hydrogen atoms that are represented by the white dots. So for any matter, the individual particles of that matter, for example, the compound H2O, are exactly the same in all three states of solid, liquid, or gas. So if we have a look at this diagram here, this diagram represents a solid, this diagram represents a liquid, and this diagram represents a gas. So it is the behavior of the particles that change in each state. So this particle or structure doesn't change. You will see the molecule stays the same. There is a molecule of water, there's a molecule of water, there's a molecule of water. It exists as a gas. When we move into a liquid, that molecule doesn't change. The particles, the molecules just become closer together. And as we move from a liquid into a solid, the actual molecule of water doesn't change. The molecules just become closer together. So it is the behavior of the molecules or particles that change in each state. So through this lesson, we have learned 4 basic concepts that I think are very, very important for you to remember here. And that is that all matter is made up of particles. And these particles are incredibly small. They are much too small to see with the naked eye. The particles can be atoms, or they can be combinations of atoms that are bonded together. So they can be atoms, molecules, or compounds. There are forces between these particles. The particles in matter is always moving. The more energy they have, the faster they move. And the spaces between the particles in the matter are empty. So you might assume that the spaces between the particles are filled with air. That is a misconception. It is not the case. They contain nothing at all. So now I want us to evaluate what you know. So what phase of matter is A, ice, B, steam, and C, water? Ice, steam, and water. So A, ice is going to be a solid. Steam is going to be a liquid. You can see the steam coming off here. And water is a liquid. Question 2. Are particles closer together in liquids or gases? Are particles closer together in B, solids or gases? And are particles closer together in liquids or solids? So here is a diagram to help you, so you can have a look at how far or close together are these particles. So A compares a liquid to a gas. How close are the particles, or where are they closer in a liquid or in a liquid or in a gas? B, are the particles closer together in a solid or in a gas? And C, are the particles closer together in a liquid or a solid? So there's our answer. Why are solids hard? So if we have a look here, we've got a solid, here we have a liquid, and here we have a gas. The reason for that is because the particles of a solid substance are packed very closely together. But there are some small spaces between them. What I want you to remember is never in an answer say that solids have no spaces. That is incorrect. If you have a look here, there definitely are some spaces between these particles. Why do solids have a fixed shape? So there are strong forces of attraction between the particles. This means that there is an orderly arrangement of the particles. The particles do not get disturbed because the particles hardly move. Why can you pour a liquid? So here is a diagram of a liquid being poured, and let's have a look at this diagram underneath here. 1. This particle falls down due to gravity. So as that particle falls down, it means that there is now a space or an opening left there. So that then means the next particle can move into the opening, leaving a new opening behind it. So the particles move about freely, but are constantly attracted by the other particles. There is no fixed arrangement of the particles, but liquid does have a fixed volume. Just remember that it takes the shape of the container that it's in. Here's something for you to wonder about. Think of a bag of cake flour. You can pour the cake flour out of the bag into a mixing bowl. But does this mean that the flour is a liquid? I want you to see if you can explain whether you think the cake flour and all other powders for that matter are solids or liquids. And here's your answer. The cake flour is not a liquid but a solid. Flour and all powders are solids made of very fine grains, which are able to flow freely when the container they are in is tilted or shaken. But the actual flour grains are solid. A very common misconception among learners is that powders are liquids because you can pour them and they take the shape of the container they are in. Please remember that a powder is not a liquid. And it's important that I point out to you that the other explanation we can say is that we cannot evaporate a powder as we can with a liquid. The powder does not make your fingers wet when you touch it. So there are several reasons that we can use to justify why flour is a solid and not a liquid. Why is it difficult to compress a liquid? We touched on this a little earlier on. Let's see if you are right. The arrangement of the particles is disorderly in a liquid, but it is more orderly than in gases. The forces between particles are stronger in a liquid than the forces between the particles in a gas. Why is it easier to pump up a flat tire than a tire that is nearly full of air? So, the air that is used to inflate the tire fills the whole tire. A gas will fill the entire space that's available to it. So that means that this is because the particles in a gas have no particular arrangements. So, in a flat tire, the gas particles are far apart, and the gas particles move about freely. In a tire nearly full of air, the particles can be forced closer together. The particles of a gas are colliding with each other, and there's not a lot of space for the particles to move between the collisions. What type of movement is found in the particles of a solid? And if we have a look at a diamond and the arrangement of particles, this is because the particles vibrate in a fixed position. So how can we elaborate on this? Well, can you take a moment to explain what happens to the particles of an ice cream when left in the sun? So when a substance is heated, the particles are given more energy. By giving the vibrating particles in a solid more energy, their vibrations will become more and more vigorous until the solid particles are able to shake themselves loose from their fixed positions. The forces between the particles are no longer able to hold them together tightly, and the solid melts. And if you join me again for tomorrow's lesson, we're going to investigate and elaborate more on this topic. Here is an interesting one for you to think about, and have a look at this diagram here. In this beaker here, we have ethanol, and in this beaker here, we have water. So how come when I take ice and I put it into ethanol, the ice sinks? How come in this diagram here that's got water, if I put ice into it, it floats? So yes, you were correct. That has got something to do with density, and we're going to learn all about that when we finished with the particle model of matter. So just to recap today's lesson, we covered the particle model of matter. We still have 2 more lessons on this topic, but hopefully after today's lesson, you are able to describe the properties of the different states of matter, and you can explain it in terms of motion and the arrangement of particles. You can explain why a model for the structure of matter is needed. You can use the model to explain the arrangements of particles in a solid, liquid, and gas. And this is leading more into tomorrow's lesson, where we are going to use the particle model to explain observed phenomena linking the energy of the particles to temperature changes. So what have you learned today? So as a final conclusion or summary for the lesson, I would like you to spend just 2 minutes answering this question about the particle model of matter. So, I used to think this about the particle model of matter, and now I think this. So this is a very good way to sum up your prior learning. So what did you think before the particle of matter? So that covers everything that you did in grade 4, 5, 6, 7. And what new things did you learn today that you can add to that knowledge? If you have any questions through the course of today's lesson, or you're sitting with any questions now, please can you email your questions to grade8@worksheetcloud.com. And thank you for joining me on this wacky Wednesday. Please will you remember that your well-being is also important on this full of wonder wacky Wednesday. So I am really concerned about you during this time and your well-being, and it's really important for you to remember to eat healthily, try and bring a little bit of exercise in, balance your time, not too much work. Your relationships are also really important. So spend some time working on those, and remember to stay happy, stay positive, and fill your wacky Wednesday with wonder. So grade 8s, thanks for watching. This lesson was brought to you by WorksheetCloud.